In this video, we're going to review some areas of some two-dimensional shapes. So let's just start with the most basic thing, units. So there are various units you can use for area: millimeters squared, centimeters squared, meters squared, and kilometers squared. And to convert from one to the other, when we're in one-dimensional length, to go from millimeters to centimeters, we divide by 10. So if we're now in a second dimension, squared to squared, we're dividing by 10 squared, which is obviously 100. Similarly, we think about the conversion between the lengths of centimeters and meters, and we know it's divide by 100. So if we're going to two dimensions, centimeter squared to meter squared means you're dividing by 100 squared. And similarly, same relation with the meter squared to kilometers squared, you divide by 1000 squared. And obviously, if you're going in the opposite direction and you want to convert between kilometers squared to meters squared, or meters squared to centimeters squared, or centimeter squared to millimeter squared, you're doing the inverse operations of these. So that would be multiplied by 1000 squared, multiplied by 100 squared, or multiplied by 10 squared. Now, there's various shapes in two dimensions. Let's just discuss the most obvious ones. So, squares. Right, rectangles. Now, these two shapes both have a length and a width. Obviously, with the square, you've got an equal length and width. So you could arguably say that the area of that is, say, if it was side length S and S, then the area is S squared. But really, it's exactly the same formula. We're just dealing with different length sides here. We take its length and we multiply it by its width. So the area of a rectangle is length times width, or LW. What about triangles? Well, triangles come in all different shapes. You've got four types of triangles. You've got the equilateral, scalene, right angle, and isosceles. And every single triangle has the same formula, where the area of the triangle is its base multiplied by its perpendicular height. Now, depending on the type of triangle you've got, the perpendicular height may be displayed through the middle of the triangle. It may be displayed on the outside of the triangle, usually shown a little right angle. But you're looking for the height that's perpendicular, so that means sitting at right angles to the base. And that gives you the formula, base times height divided by 2, or you can write it as 1/2 base times height. And that's your perpendicular height. Now let's look at rhombuses and parallelograms. Alright, so let's start with a parallelogram. So a parallelogram is longer than a rhombus in one direction. Okay? So usually you're given the dimensions of the base and the perpendicular height. Remember, that perpendicular height could be inside the parallelogram, or outside the parallelogram. Now the area formula for this is base times perpendicular height. Now that formula applies to a rhombus as well, and of course a rhombus is like equal sides all the way around. If you are given the base of a rhombus and the perpendicular height to that base, you can use this formula to work out the area of the rhombus. However, there's another formula for the area of a rhombus, and this is all to do with the fact that the lengths are the same size. So this wouldn't work for the parallelogram. So if you have been given the diagonal lengths of the rhombus, so let's arguably say that's one diagonal from one corner to the other, and the similar diagonal from the other corner down, if you've been given those lengths, let's say that that length there that I've done as a dotted line is X, and that length across there is Y, you can also work out the area of this parallelogram, this rhombus, by going 1/2 X times Y. Now what's important is that you know how to use these formulas. Anyone can learn formulas. It's can you use them, can you substitute the values in correctly to be able to use these formulas. So for example, if I'm given a rhombus with a length of 3 centimeters and a length of 7 centimeters, the area is going to be 1/2 multiplied by 3 multiplied by 7, which of course is 1/2 of 21. half of 21 is 10 and a half. And we're in centimetres squared.